In order to see how approximating slopes leads to a slope of a tangent line sometimes, we're going to consider the curve y equals the cosine of pi x. On this curve is the point 1/2, 0. You can check that on your own. And what we're asked to do is consider various points that we're going to call Q that have x coordinates of 0, 4/10, 49 hundredths, 499 thousandths. You might notice that those are approaching 1/2 from the left, right, from below 1/2. And then 1, 6/10, 51 hundredths, 501 thousandths. Those are approaching 1/2 from the right, or from numbers above 1/2. And as a big picture of what we're doing with this, we're going to find all of those slopes of the secant lines and then guess the value of the slope of the tangent line at the point 1/2, 0. And we'll see what that looks like in just a minute. And then once we've made our guess, we're going to find an equation of the tangent line and then graph the curve, some secant lines, and the tangent line itself. We're told to use a calculator. What we're actually going to do is we're going to use Excel. And I've set up an Excel spreadsheet here. I've got a column here that has X values. You can see that they are going from 0 to blah, blah, blah to 0.499 to 1/2, and then from 1 down to 1/2. So that's approaching 1/2 from numbers smaller and numbers greater than 1/2. To use Excel here, this cosine pi x that I've put in this cell here, that's just a note to myself of what it is that I'm computing. But if I'm actually going to do this, then I'm going to type an equals cosine, and Excel recognizes the cosine function, and I'm going to use pi. Cosine recognizes pi as a function, but it's got to be a function with no argument. So pi with parentheses times, and then I'm just going to click to the left here. Bam, there, A2. And end the parentheses and hit enter. And it's telling me that the cosine of 0 is equal to 1, which we knew. And then I'm going to bring this all the way down, and it's going to flesh out all of these values for the cosine of pi x. You'll notice at 1/2, it says, at scientific notation, 6.126 times 10 to the negative 17th, but we know that value is supposed to be 0, so I'm going to go ahead and fix that. And what we're looking for is going to be slopes. Now, each time I compute a slope, what I'm doing is I'm going to find the slope between 0, 1 and 1/2, 0 for the first one, we'll say. So I'm going to say that this is equal to, and then I'm going to use the slope formula, right? y2 minus y1. So y2 minus y1. So that's b2 minus b6, right? 1 minus 0, divided by x2 minus x1. Now, if I hit enter there, I get a slope. It's -2. And if I were to click here on this little green box and drag this formula down, then what it would do is it would give me the slope between 0, 1 and 1/2, 0 first, right, as -2. And then it's going to give me the slope between 4/10 and 0.309 and 0.501 and negative 0.003142. That's not what I want. What I want is to keep using this here. And so what I'm going to do is what's called absolute referencing. This A6 and B6, I want them to stay put. So on a Mac, I'm going to use Command T. If this were a PC, I would use Shift F4. It puts in $signs, and what that does is it locks in that cell reference. And if you wanted to, you could just type in the $signs yourself. And then I'm going to drag this, whoops, oh, I guess I'm going to hit enter. And then I'm going to drag down the formula. And what it's going to do is it's going to give me slopes. And you'll notice that in all the cases here, it's giving me slopes between the point of interest, say 0.49 and 0.0314 and 1/2, 0, right? So for every one of these, it's going to reference 1/2, 0, which is what I wanted. And you'll notice that with one of these, it says division by 0. That's a problem. Well, of course, it's subtracting itself. So we're going to hit delete on that. Now we're going to look at these values here. Oh, maybe I can tell here this slope. And now we're looking at any trend that we see in the numbers here. I see it's going from -2 to -3.09, -3.14, -3.14, -3.14. I'm going to say that that's pi. Excuse me. I'm going to say that that is negative pi. So, oh my goodness. I had to tell Excel that I wanted that entered as text, and then I took a screenshot. What we can see here is if I look at numbers approaching 1/2 from below 1/2, or from the left, if you're thinking about this as an XY situation, then the slopes are going from -2 to -3.0 to -3.1 to -3.14. They're tending toward pi. And then if I approach 1/2 from the right, from numbers bigger than 1/2, I have the same trend. They're going toward negative pi. So that's part A here. And then part B was, using the results, guess the value of the slope to the tangent line. So B, we're going to say the slope to the tangent line is negative pi. Part C, using the result from part B, find an equation of the tangent line. So we're going to say y is equal to negative pi times 1/2 plus b. And from this, I get that b is equal to pi over 2. So I'll put that together. Y is equal to negative pi x plus pi over 2 is the equation of the tangent line. And then we're to sketch the curve and a couple of the secant lines. Now, for presentation purposes, I'd like to do this using a graphing utility, but I want you to see how we can quickly sketch the graph of something like the cosine, y equals the cosine of pi x. The period is going to be 2 pi divided by the coefficient of x, so 2 pi over pi, which is 2. And so I'm just going to mark a 2 on the x-axis here, and a 1, and little marks at 1/2 and 3/2. And then we'll go ahead and come over here, negative 1/2, negative 1, negative 3/2, negative 2. I'll give myself a little bit of height, so I'll label my y-axis there. And the cosine curve has a 0 at, I mean to say it has a y-intercept at 0, 1. And because it's periodic, that's going to happen at the beginning and the end of each period. And then halfway between the two, we have a minimum. And then we just connect the dots with a smooth curve. There's our curve. And then the point of interest was 1/2, 0. Now we were asked to sketch a couple of secant lines. And so one of these goes through the point where x is equal to 1. And then I'm not going to be too particular about a second one. But then we're to draw the graph of a tangent line, which I've done here. And it's the line that touches the curve at only one point. Now we can see here the slope is negative. I can't tell that it's negative pi from this graph, but and the y-intercept is supposed to be at pi over 2, which is about 1.5, 1.57. And so it looks like we've got something that's about right. And you can double check this with the graphing utility and see that everything works out. Now I'm going to expand on this just a little bit. Let's suppose that the curve that we were given, y equals the cosine of pi x, was the position of some particle. Then the slope, being change in y over change in x, would be given in distance divided by time, right? The position of a particle at any point in time would have units that correspond to velocity. And so what would be happening here is that the slope of the tangent line would be giving me a particle's velocity at a particular moment in time. That's something that we will expand on later in this course.